bring that back in like that, hit play, and like that you've got yourself a cloud generator for any level you like. Hello guys, John Stayskull here. Welcome back to another game dev tutorial. So in this video we're going to look at how to create a cloud generation script and system from scratch, which spawns clouds into our scene at different intervals and speeds and different scales. It's going to be a great addition to our game dev toolbox. Okay, let's get into it. Now you can see in this sample scene here, I've got 4 different cloud prefabs that are just running across the screen here. So what I want to do is I want to effectively make an auto generation system which grabs these clouds from the library, spawns them over here somewhere to the side of the play space, then gets them to animate in at random speeds, kind of overlapping in a nice organic way, and then eventually getting out of frame and destroying and starting the process again. So I think that'll be quite fun and quite useful in your own games. And you can imagine using this for even spawning enemies and things like that. So this sample scene here, I'll make this available for you guys in the description of the video. So if you go down there, you can download this sample scene with these 4 different cloud prefabs, and you can kind of follow along from there. And if you're a Patreon supporter, like these guys up here, thank you by the way, you guys are really cool. Thanks for supporting this channel. If you're a Patreon supporter, you will get a link to the complete project. That is all the scripts already working, everything intact, ready to use in your own game, as well as all the different project files from all the past tutorials as well. So with one of these clouds, we'll just click Add Component, and we'll say New Script, and we'll type Cloud Script. Click Create and Add, and we'll just pop this script open by double-clicking the script. So the first thing we'll want to do is create a bunch of properties here. We'll say private float speed, and we'll just set this to like 2 for the moment. And down here in the update, we're just going to do a transform.translate. Then we'll do vector 3 dot right, so we're orienting the vector to the right, multiplied by time dot delta time, and here we'll multiply by this speed factor we've created up above. I'll just put these in parentheses. So I'll run that. Okay, really cool. Ship it. We have a complete game. Not quite. So we've got a few more things to do. So the first thing we'll do, now that we know that kind of works, we'll just apply these changes we made to that prefab. And I'll just delete these other 3. So now that we've created a script for 1, we just want to bring that script over to the other 3. And we can do that by going down here on the inspector for that script and just clicking this little icon and clicking copy component. And then if we go into our prefabs folder, we've got clouds 1, 2, 3, which don't yet have the script. So we're just going to hold shift and click and select all 3 of them. And then we'll just click the ... icon of any of the other components. And in this case, I'm clicking the sprite renderer, and here we can paste component as new. So watch this. Click. Now that's added the script, not only to 1, but all 3. So now if I was to drag any of these 3 from the library and press play, they should all move. It's beautiful. Absolutely beautiful. Masterpiece. 10 out of 10, IGN. So we can delete these clouds now, because the next step, we want to actually auto-generate them, right? So right-click in our scene view, create empty, and we'll call this one Cloud Generator. And we'll just position this to the left here somewhere, because we want to kind of spawn them out of the field of view. And what we'll do, because this is an invisible object effectively, we'll go over here to the inspector and we'll click this little 3D cube icon. And this allows us to pick one of these capsules or icons to assign to this. It just makes it a bit easier to see invisible objects. So we're going to be spawning the clouds from this location over here somewhere, which also means we need an end location, right? Now we could hard code a value in, like we could say stop the clouds over here somewhere, but a nice way to do it instead, make a child game object. So by clicking the cloud generator, right click, create empty, and that'll create a child. And we'll just call this one end point. And similarly, we'll give this one also a, we might just give this one a like a smaller marker. And now if I drag this thing across, so that's our start point, and that's our end point. So the next step now is to create the actual generator script. So with our cloud generator selected, we'll go to add component over here, new script, and we'll say cloud generator, and we'll call it script just to make a differentiation between the game object and the script. Okay, so we'll double click the cloud generator now. So we have a new cloud generator script. So we'll start by defining a few properties at the top here. So the first one we'll make of type game object, and we'll make this an array. So this is pretty cool. If you guys aren't familiar with arrays and stuff, this is pretty cool. And those of you who are will be just like, shut up. It's not so exciting. It's just an array. But you know, the people watching these videos are of different skill levels, so you know, have to try to make content for everyone. So we'll serialize this field because we're going to drag the clouds into this array through the inspector. And we'll also make a float, we'll call it spawn interval, and this will be the interval at which, like the frequency at which we spawn. We'll serialize that. And, oh yes, we need to also define the endpoint, game object endpoint. And we'll serialize that. And what else may I need? I might just actually also just make a vector 3 to store the start position. Often that'll come in useful, and I predict it probably will. So when this cloud generator starts up, I might just assign this start position that we just created up above. So start position equals transform.position. So the transform position of this particular game object is a start point. Just saves us constantly referencing that, you know, it's a bit shorter to do it that way. And then we will want to actually spawn the clouds. Before we do that, I might just go back to Unity IDE and assign some of these values here. So you can see now our clouds array is exposed here, and our spawn interval as well as our end position. So what we'll do, we'll start with the end position. We can just click that end position and drag it into the serialized field. So now we have a record of that. Spawn interval we'll set to 1.5 seconds. So every 1.5, something like that, the cloud will spawn. I've built cloud spawners many times before, so the kind of timing is not too unfamiliar to me. I actually use something similar to this in my own game, Blood And Mead, where I spawn the clouds in a very similar system. That game's currently available to wishlist if you guys want to check that out. I'll put a link down below. It's going to be really cool and really awesome with a lot of moving clouds for you guys to marvel at. Alright, so we have 4 clouds, so we can type in 4. And what this does, it just creates the slots for the array. And we can populate this in a few different ways. We can click these knobs here, and we can assign them like this. or we can go to the prefabs folder and we can drag them from the prefabs folder like this. And there are other ways to do it. Well, you know what, I'll show you one more while we're here, because these videos are all about teaching as best as we can. So I'm just going to delete those again. So check this out. This is a really cool trick. I'm going to lock this array, this inspector panel. See this padlock up here? Click, it's locked. What this means is no matter what else I click on, it's still showing me the cloud generator inspector panel. Now check this out. I'm going to shift select all of these clouds and just drag them to this clouds name, and watch this. Boom. How cool is that? So back to this cloud script. So now we want to loop through that array and start spawning these clouds. So I might block in a few different functions. I don't think I need this update, so I'm just going to get rid of that. I might make a void spawn cloud. So we'll say game object cloud equals instantiate. So we're going to target the clouds array now. And we're going to grab, and using an index, we're going to reference. And here we're going to use a random number. So we'll say Unity engine random dot range. Not to be mistaken with this random range here. This is actually deprecated, which means it's no longer being supported by Unity. They should probably get rid of it at this point. But random dot range. And here, the first value we'll type in 0, and the next one we'll type in 4, because we have 4 different types. So what this is going to do, I might actually just break this out to make it a bit more easier for you guys to understand. So I'll say int random, oops, what's going on, my caps lock, random index equals, and then we'll pass in the random index here. So just a little correction here for you guys. Instead of using the number 4 for the random number range, use the length of the array as I've illustrated in this red box. Then we'll say cloud.transform.position equals start pos. So we're just going to call that now. So in the start, we are going to use invoke. You know what, I'll make another function, right? And this is probably better practice. Attempt spawn. And do here, we'll use the spawn interval. So that's gonna, so let's make this function called attempt spawn. And here we're just going to call the spawn cloud function. So why have well, first of all, what are we doing here? Okay, so when this generator object starts, it's going to call this function attempt spawn after the spawn interval, which is 1.5 seconds. This invoke, you don't have to use invoke. You can use a coroutine. You can use some kind of delegate through a tweening engine. I'm using invoke in this particular case just because it's easy to write and it's easy for beginners to follow, and there's absolutely no harm in using this for a small project example like this. But just know that invoke is a little bit slower than using a coroutine, and that's mainly because we're using like a string literal reference here, which is a bit more slower to process. But for now, it's fine. Don't sweat it. So, and then in this, we are going to call this attempt spawn function here. So why are we creating this and not just calling this directly? Well, having this kind of intermediary function allows us to do things like checking if the game is still in play, you know, is the level over, is the player alive, how many clouds do we have on screen. So you might want to just do some kind of checks here, check some criteria, and then spawn the cloud. In this case, I'm not going to check anything, but I'm just going to call this spawn cloud function. And what we'll do then, from in this attempt spawn function, we're just going to recall this invoke. So this is just going to create a loop which continuously calls this function every 1.5 seconds. So I'm just going to run this. So I should have pulled this down a bit earlier. This is kind of a bit suckful. So I'm going to run this now and see what happens. I don't know. We're kind of we're kind of coding on the fly, guys, so we may run into errors, hopefully not. Whoa, look at this. Yeah! So check this out. This is cool. So every 1.5 seconds, and you can see the clouds are different. Each one is pulling, and you can see here what's being created. Cloud 2, Cloud 1, Cloud 3, Cloud 0. When I created that cloud generator object, for whatever reason, Unity decided to stick this thing at minus 303 position in world space. Don't ask me why. Don't ask me why. I will just say 0. How about that? I'll just run that again quickly. All right, okay, we can see it now. Nice. So you'll notice a couple of things here. These clouds are just going on forever. So what we want to do, we want to use that endpoint now to stop the movement. So we'll do that now. I'll just speed up this workflow a little bit for you guys. I know we're kind of running a bit high in time. So back on the cloud script, we need to tell this cloud where the endpoint is. So what I might do here, I'm going to create a public function on this cloud. Say public void start floating. And here I'm going to tell it, give it some parameters. The first one being speed. The second one being the end pos x, so the end position x. Right, and here we're just going to map this speed up here to this speed here. In case you're wondering why I did the underscore, that's just a convention because it's a private variable, and it also helps to differentiate between the stuff that's coming through as an argument and the stuff that's like a class member property. So we'll make another one. We'll go end pos x equals end pos x. And if you just hover over there, press Control, and then hit the full stop, we can automatically create that. Or you can write it in yourself. And it also means that we don't need to assign the value there. We'll get rid of the start function because we're not going to be using that. We're going to be calling this directly from the cloud generator. Now in the update, so this is how we're going to destroy it. We'll say if transform.position.x is more than the end position x, then destroy this game object. So now we just got to call this function and pass in these information to this class. And so I'll do that here just after we've spawned it. Cloud.getComponent, and we'll say cloud script, and then we'll say start floating. So that function is exposed to us. And now we need to give it the speed and the end position. So for the speed, I'm thinking to give it a random speed. So we'll say Unity engine dot random dot range, and we're just going to say I'll say 0.5 f, comma 1.5 f, and so this is the thing sometimes, guys, when you're trying to do calculations inside parameters, it just makes it a bit hard to follow. So what I'll do, I'll just make a float outside here, and I'll say speed equals Unity engine random.range. Yep, and then we'll pass in the speed, and for the end position, we'll say endpoint because we know the endpoint, don't we? Because we created that object. Dot endpoint dot transform dot position dot x. And while we're here, what we might want to do, you may have noticed that the clouds, they were all going in one kind of very specific line, and they were all relatively the same size. So I think it'd be nice if we kind of randomized the scale a little bit, and also maybe the vertical position. So let's do that now. So just follow along here if you can. Start pos.y equals Unity engine once again, random dot range, and we'll just go start pos dot y minus 1 f to start pos dot y plus 1 f. So that should now change the y position, right? Because we've modified the y position, and now we've assigned this start position back to the cloud. I know this probably makes no sense to anyone, but I'm doing my best to keep this kind of somewhat coherent. So I hope very much that you guys are able to follow my ramblings at this point. Right, so finally the scale I wanted to modify a little bit. So I'll just make another float. I'll call it scale, and I'll say equals Unity engine dot random dot range. And what I'll do, I think I might just do like a 0.8f to like a 1.2f. So that would just give us a bit of variation, not too much, not too dramatic, and you can kind of play with that if you like. So now we just need to assign this scale to the cloud. So we'll say cloud dot transform dot local scale equals new vector 2, because we're in 2D, scale. So scale for the x, scale for the y. Now you could create separate scales for the x and y if you wanted to really create different type and shaped clouds. That could be a nice way to really create a nice range of unique shapes. But for now, I'm just going to change the main scale. Here we come, we've got clouds. Right. So it's working, but I'm going to make a tweak. I noticed that it's sitting a bit high for some reason. Now, which is kind of strange because the y position, start position -1. Huh. So I'm just going to go -2 on this and see what happens. It's kind of odd. Because I would have thought it's going to start below this point and then come a bit higher, but I mean, it's kind of interesting, right? But it's not exactly what I was hoping for. Wow, it's really going low. What's going on here? Okay, something is messed up. Okay, I see what's going on. So you may have picked up on this. I'm actually modifying this class member. So I'm subtracting a position from it through this random range. So what I'll do here, instead of doing it like that, I'll say new vector 3, and I'll say start pos.x, because we have no problem with that, and we'll then turn this into a float here, and I'll say start y, and we'll say start pos. I keep the Z in there because sometimes, depending on the position, it can be sitting behind the camera, in front of the camera, or behind the background. So just better to track the Z sometimes too. So let's jump back to Unity, hit play on that. All right, that's looking pretty good. Got a nice kind of grouping of clouds, different speeds, quite organic. If you're optimizing things like clouds like this, you may want to do something called object pooling, where instead of destroying the clouds, you're actually putting them back into like a data array and you're cycling them. I don't want to get into that in this tutorial because it's quite complicated, and I'd probably dedicate a separate tutorial to that. But for now, this seems to work just fine. And so the one thing you'll notice, I'm just going to finish this off with one very useful thing. So you'll notice that when I hit play on this, there's no clouds, right? Because the clouds are getting generated out of screen, which is kind of not so cool, because you want it kind of, when your level starts, you want there to already be clouds. In Unity, I think this concept is known as pre-warming, which is used in the particle system. So what we're going to do, we're going to create some clouds that are already in the scene. So in this cloud generator function, I'm just going to go down here and create one more function called pre-warm. And what we're going to do here, we're just going to create a loop. If you type 4 and then you hit tab button twice, 1, 2, it'll auto-complete the structure for the for loop. So anyway, we might say 10 because we want to generate 10 clouds. I'll say vector 3 spawn pos equals, and we'll say start pos plus vector 3 dot write multiplied by, in brackets, I times 2. So finally we call the spawn cloud function here. So we're just calling this spawn cloud function 10 times. So to finish that off, we just got to call that pre-warm function at the top here. I just want to pass in the start position here. So we're going to just modify this a little bit. So vector 3, we'll say start pos. So that way we can use it here. Right. So here, attempt spawn, start position. So all I've done is I've just created a change so that we need to tell the cloud where to spawn. So I kind of need that for this pre-warming functionality, because I want to kind of spawn them at specific points. So hopefully this spawns a series of clouds across the screen and then continues on by spawning the other clouds. Whoa! Perfect. That is exactly what I was hoping for. So we just marvel at these clouds for just a moment. You know what? Actually, let's run this full screen for full effect. Beautiful. Look at that. I like this kind of grouping here where they overlap. That looks quite nice. And you can obviously elaborate on this a lot more. You can make the clouds that are smaller go slower to create a feeling of depth. So it's like the ones that are further away are slower. You can also change the opacity so that some are more transparent than others. And you could even generate enemies like this, right? Like some kind of flying arrows or traps. You could make these like collidable objects that when you touch them you lose health, and you've got to get the player to dodge at them. So this kind of system, though we've used it to create clouds, is quite useful for any number of different scenarios in different games. And once you've created this cloud generator, you can then drop that into your prefabs folder. You can delete that. And whenever you like, whatever project you're using, you can just bring that back in like that, hit play, and like that you've got yourself a cloud generator for any level you like. Alright guys, I hope you found this video useful. If you have, make sure you give it a big thumbs up down below for me, and make sure you're subscribed if you haven't already. I have plenty more game dev tutorials like this coming up. Alright, all the best guys, see you in the next video, and as always, all the best on your game dev adventures.